Lesson 8, greater than and less than. When we compare values, anything that we see on a number line that is to the right of 0 is greater than 0 or bigger than it. Now, if I was to go down to -2, we would see that 0 being to the right of it is actually greater than -2 and 3 and 7. All these numbers are greater than -2. Similarly, -10 is the least of all these numbers, so that we could say if we wanted 7 is greater than -10, and so on. We can write that as follows. 0 is less than 3, and 0 is less than 7. We can also say, for example, that 3 is greater than 0, and 3 is greater than -2. This is the less than sign, and you can see that the left side of it is smaller and the right side of it is bigger. So reading left to right, the smaller expands to the bigger. This is the greater than sign, and we can see that the opening contracts down to a smaller end. So when we read it left to right, 3 is greater than -2. Here's our basic number line, which extends to -infinity and +infinity, and I've just marked a 0 on it. Let me make a few more. On each one, let me mark 7. Here and here. We don't need to worry about any other numbers. We'll just look at 0 and 7 for now. Well, I want to show you how to plot x is equal to 7. Well, it's just very straightforward. Put a fat dot on the 7, and we're done. Now, here's one. X is not equal to 7. Little line through the equals. Now, this is a bit of a funny one, because what it means is that x is equal to everything else except not 7. Everything else but not 7. Here's how it looks. We take a circle and leave it open around the 7. And then we want everything else to count. I'm going to try to show every other number that can exist except 7 by putting a fat arrow like this. This is x is not equal to 7. It's like an inverse selection. Now this is about greater than and less than, and so far we've done neither. We've done equals and not equals to, but I just want to show you how that works. If I want to show x is greater than 7, then what I would do is put an open circle so as to not include the 7, and then do the right-hand side of the above diagram. It goes to infinity. 10, 100, a bazillion. I don't think that's a real number, but not 0, for example. And x is less than 7 would look like this. Open circle so as to not include 7, and then we go to -infinity. So just have a look at those 4 different arrangements for a moment, will you? Well, here's some number lines, and we're looking at -2 compared to 0. So first of all, what would x equals -2 look like? And what would x does not equal to -2 look like as well? First of all, x equals 2 is just a big fat dot on the 2. And x is not equal to 2 means it's an open circle, but also every other value is included. And this is somewhat unusual. Sometimes if I've got a blue cloth and I say the cloth is not red, that doesn't mean it's every other color as well. But here it does. X is every other color. Now, I want to introduce another symbol. Ready? Here it comes. X is greater than or equal to -2. And what I mean by this is that x can be -2. In fact, it is -2, but it's also anything greater than it. 0, for example, or 10 million, but nothing less. compare that simply to x is greater than negative 2. Well, x cannot be 2, so make that circle open. And then draw a line, a fat line that goes all the way up like this. There's only 2 left. X is less than negative 2, and x is less than or equal to negative 2. What would they look like? Well, x is less than negative 2, and x is less than or equal to negative 2. For it to be less than, we have an open circle. What color? Oh, let's use yellow, and it goes down forever. X is less than or equal to negative 2 means negative 2 is part of it. And when I draw this arrow in, these 6 combinations represent every different relationship that we can have. Go to the practice now and try drawing a few. I hope that worked. Thank you.